Okay, functions, today we started something new. We talked about radian measurements. So something that you're going to want to do is go into Canvas where you found this video, and the link to this video right here is going to help you, and then there's a link to a demonstration. So that's all posted on Canvas for you. I can show you that. So if you go into Canvas, into our class, we are in Unit 8. So if you go to Unit 8, right here, this is one of the videos I posted, but what is a radian? That is a video, and then the demonstration is right here. Today's video, the one I'm currently recording, will be right below it. So make sure you look at those two things. Okay, so let's get out of this. Now, something that we talked about in class today is that if you give me a measurement and it's got it doesn't say that it's degrees, if it doesn't tell me that it's degrees, I'm assuming that it's radians. So if you tell me an answer is 120 degrees, but you don't do that little circle that indicates degrees, then I'm going to assume that you're telling me it's 120 radians. So it's going to be really important that we identify what we're doing. You don't need to write radians. It's always going to be assumed that it is radians unless otherwise stated. So that is the flat line. So some people wrote this down, some people didn't. All right, so this is the definition of a radian. So go ahead and put this in your notes. You can hit pause right here to put this in your notes. And then to multiply, to convert between degrees and radians and degrees. So this part right here, to convert, this part right here, if we are going from degrees to radians, this is what we're going to do. We're going to multiply those degrees by pi over 180 and then simplify to convert to radians. We are going to leave radians in terms of pi unless I give you something that is like, 14.7 degrees. If we were to convert that, I would go ahead and just keep that as a decimal. But otherwise, we are going to keep all radians in terms of pi. So then let's multiply a radian. To go from radians to degrees, we're going to multiply that radian. So let's say our radians are pi over 4. Well, to get the degrees, we're going to do pi over 4 times 180 over pi. Pi simplify, and we end up with 180 over 4, which just gives us 45. So that is what we were doing. Let's do some work. So we're going to multiply 45 degrees, and we're going to multiply that by pi over 180. So what we are going to do, so we're going to leave this in terms of pi. So we can't just type this in our calculator. We're going to get 45 times pi over 180. We need to simplify these numbers. So I'm going to end up with something over pi. Well, 45 and 180 have 45 in common. There is one 45 and 45, and then there are 4 45s in 180. So we end up with just pi over 4, which is what we got, pi over 4 radians. So again, so 1 pi over 4. We need to leave this in terms of pi. So then we have negative 270. We're going to multiply that. So then we end up with negative 270 pi over 180. Well, I can divide 90 by both of those. So 90 goes into 273 times, and the pi stays there and it's negative. And 90 goes into 182 times. So I end up with negative 3 pi over 2. So again, we're simplifying the numbers. Now this one is a decimal. So this one, I am going to type this in my calculator exactly the way I see it. So I'm going to type, if you take your calculator, you're going to type 249.8 parenthesis, and then your pi button is second, the caret key right above the division sign, divided by 180, close that parenthesis, hit enter, and you should have gotten 4.36 radians. Now, one of the things that we need to think about is if I didn't have the word radians here, I would just assume that it's radians. So we don't have to have that word radians. But because it's the first time we've seen it, I'm going to go ahead and have it there for you. All right, now let's go the other direction. So we've got 9 pi over 4, and we're going to multiply that by 180. So this is all multiplication. So if we type this in our calculator, we can type this all in our calculator like this, but then we can notice I have pi over pi. This becomes a big 1. So then I just have 9 times 180. So I end up with 9 times 180 divided by 4. And I end up with just 405 degrees. Notice I've got my degree symbol, so I don't think it's 405 radians. Okay, we're going to do the same thing here. So we're going to multiply that. The pi's simplify out. And I'm left with 5 times 180 divided by 6, and I end up with negative 100. Whoa! I thought they fixed this. Negative 150. Okay, I have just 4.25. Nothing's telling me what it is, so I'm going to assume that it's radians. So I'm going to type exactly what I see in my calculator. 4.25 parenthesis 180 over pi, which again is second the caret key, which is right above the division sign, and I get roughly about 243.51 degrees. Okay, so that's converting back and forwards. We'll do some more practice with it. Here's a table that I had everyone put in their notes. You can go ahead and hit pause and put this in your notes. And this is something that we did. So to put this chart into perspective, to make it make a little bit more sense, we went ahead and we drew this. Now, I came up with these numbers, so if I start at 0 degrees, I get 0 pi, or just 0, right? But to get 90 degrees, so this is 90 degrees, I could have done 90 degrees times pi over 180, which is equal to 90 pi over 180, and then I can simplify that. There are two 90s, so 1 pi over 2. That's how I got pi over 2. I can do that for all of them, so that is what I did. But these are the main ones that were just on the last screen, so I put them in. 180 was pi, 270 is 3 pi over 2, and then if we go all the way around, we're at 2 pi. So here we have this, and we're going to say that this is 30 degrees. This has a reference angle of 30 degrees, so it's really 150 degrees. And this has a reference angle of 30 degrees, which is really 210 degrees. And this one has a reference angle of 30 degrees, which is really going to be 330 degrees. Okay? So we use those reference angles to help us. And then if I did 30 degrees, this one was given, is pi over 6. But to find this one, we said it's 150. We're going to do 150 degrees times pi over 180, which is going to be equal to 150 pi over 180, which is equal to, well, there are 30s in both of those. There are 5 pi, and then those are 6. So 5 pi over 6. So this is going to be 5 pi over 6. So we could go all the way around, so feel free to fill in the rest of them. Then we can do this one. This is going to be 45 degrees. And again, all of these are 45. All of these have a 45. So this one right here would have 45 degrees, but then it's also 135. Again, to do the math, we're going to do 135 times pi over 180, and we end up with 135 pi over 180, and that gives us, we can divide both by, looks like, so we can divide both of those by, by 45, and we get 3 over 4. So 3 pi over 4. So that's going to go over here, 3 pi over 4. And then we get pi over 4 on that one, which we had already found. Now let's work our way backwards. So I get pi over 3. So if I get pi over 3, I need to multiply that by 180 over pi. Those simplify, and I end up with 180 over 3, which is 60. So this is going to be 60 degrees. So from here to here, oops, didn't draw that wide enough. Hold on. from here to here is 60 degrees. Then this is going to be 120. So 60 degrees is my reference angle, 120 degrees, and then to find that one, we're going to do the same math. We're going to do 120 times pi over 180 is equal to 120 pi over 180. And those simplify down to, we can divide both by 60, and we get, there are 2 pi over 3, which is what that is. Okay, so what I'd like you to do is finish the rest of this. Go ahead and hit pause and do that. Okay, so now what we have is the tangent of 2 pi over 3. So we're going to go ahead and convert that into degrees. So if we convert that into degrees, here we go, there we go. We end up with 2 pi over 80. Again, the pi's simplify, and we end up with a tangent of 120. Okay, on the test, what I'm going to expect you to do is to write this out. So 120 is right here. This is 120 degrees. That means my reference angle is 60, so this must be 2. This must be the square root of 3, and this is on the negative side of x, so it's negative 1. So tangent is opposite over adjacent, so negative square root of 3 over, the square root of 3 over negative 1, which is the negative square root of 3. We're going to do the same thing with sine. We end up with the sine of 270. Now remember, this is one of those quadrantal angles. So 270 is right here. We can choose any point we want. I always choose the easiest. So x is 0, and we'll use negative 1. So now I know my x, I know my y. I got to find my r, which is the square root of 0 squared plus negative 1 squared, which is r is equal to the square root of 1. And so r is equal to 1. Sine, if I remember correctly, is y over r, because it's opposite over hypotenuse, and y is always opposite. So then I end up with negative 1 over positive 1, which is sine is equal to negative 1. Then we got to do the cosine of 4 pi over 3, and that is going to be in the fourth quadrant, so we need to do 4 pi over 3 times 180 over pi, which is equal to 4 times 180 over 3, and we end up with 4, that gives us 240, oops, there we go, so we end up with negative 240 degrees, so negative 240, so we have to draw that. And so we start here, we go down, and that's negative 90, negative 180, and we get about right here. We need to find that reference angle, so negative 180 minus negative 240. So if we type that in our calculator, we end up with a 60 degree. Oh, look, that's just like this one right here, right above it. So then I end up with a cosine, which is adjacent over hypotenuse. So I get so I have negative that, which is going to be negative 1/2, and that is my final answer. Okay, if you have any questions, come to class with those questions. Otherwise, I hope you have a great weekend, and I'll see you on Monday. We'll do lots of practice of this